So when is you guys' final? Next week? Monday? Okay. So here I am going through the old exams that I covered throughout the year, plus 2 other problems. Okay. So I just basically went through this, found a few problems which I thought you guys should know. And then if you guys have problems that you want me to do, just bring them up, and then I will try to explain them. Okay. So this is that, like, we have the room booked till 8:30, but it probably won't go that long. The first, are we good to start? Yeah. The first problem is from practice for 3. Let me write that. We have to show that it's homogeneous and solve. So there's 2 methods to showing that it's homogeneous now. Okay. So the first method is we have to try to convert the equation to have y over x terms. But first we need to solve for dy dx before we can do any of the methods. dy over dx is y prime, which is equal to f of x y. If we solve for that, we have 4x squared here divided by 2xy. Okay. Y over x. So by separating this fraction, plus y over x. Right here, x over y is as 2 times y over x negative 1 plus s times y over x. So we effectively made the function a function of y over x. Therefore, we know that it is homogeneous. Method. This method is nicer in the terms that when we do our substitution, y over x is equal to v, and we've already got it in that form. The other method is quicker in knowing whether it's homogeneous or not, but you can do either, is we can multiply t to every x and a t to every y. So we will have 4 times the quantity squared plus 3 times the quantity squared divided by 2 times tx times ty. If we simplify that, we have 4t squared x squared plus y squared divided by 2t squared xy. Well, that all the t squareds will cancel out, and we're back to the function of just x and y. So therefore, it's also homogeneous. Why do we know that it's homogeneous? So that we can do the v substitution. That's one way of solving it. For v is equal to y over x. Y is equal to times x. Are we good with this? Proving homogeneity. So then y prime is equal to v derivative of x is 1 plus x times b prime. So this quantity is equal to y prime. You know, this was, right? And we found it, and we know our v equals to y over x, 2 divided by v plus v divided by 2. Sorry, 3 divided by 2. Okay. Now we can try to isolate v over dx. Let's try to isolate v prime. That's equal to v. And then if I subtract the v here, I am left with v over d. Okay. We want the x terms on one side and the v terms on the other. So we can do 2v over 4 plus v squared times dv is equal to dx divided by x. We all see that? So then when we do the integral of both sides, we can solve. What would this be on the left? This is a natural log of z squared plus 4. Because it's du over du situation. This is equal to, again, dx is the derivative of x, so it's natural log x plus. Now, we can solve for okay. We can combine these natural logs, right? If I bring this to this side, I have the natural log of b squared plus 4 minus the natural log of x. That's the same thing as a combined natural log of b squared plus 4 divided by x. And when we try to cancel out the natural log, we are left with b squared plus 4 divided by x equals plus or minus e to the c power. And this can be like equal to 1 or something. There's one other step that we need to do. So as your final answer, you can state y over x quantity squared plus 4 divided by x equals to 3. And the actual, or you can multiply the x across and then state that as an answer. On this problem, raise it. We're going to do Wronskian because I remember that being on the exam. So y1 is equal to 4x, y2 is equal to 3 e to the 2x. Okay. So the Wronskian, the one thing that you have to remember, if you want it to be linearly independent, what does the solution, like what is the outcome that you want? It can't equal 0 if you want it to be linearly independent. Okay? You have to remember that because I remember on the exam I wasn't sure and I went with some answer. Okay? Yeah. Actually, make sure you check that because it may be you don't know. We know that when it's not equal to 0, then it's linearly independent. I'm not sure when it's equal to 0 whether it is definitely linearly dependent. But the way to do the Wronskian, you have e to the 4x and 3 to the 2x. So for the second row, we fill it with the derivative of the top. So the second row will be 4 times e to the 4x, 6 times, and then we solve them. So this is equal to 2x, 4, 4x. So it's 6e. What was the exponent on EV? 6x. Add them. Minus 12. 10 minus 6. So we know it's linearly. Any questions on that? So you take the derivative of the, yeah. And then if you have 3, take the first derivative, and you take the second derivative, have a 3 by 3. But on the exam, they will not ask. They won't ask you to solve a 3 by 3 matrix. That would be annoying and big. But remember that when it's not equal to 0, linearly independent. Okay. And I am not sure when it's equal to 0. It might be linearly dependent or may not be. So make sure you check that. All right, I'm going to take it away now. Okay. We have to determine the homogeneous equation. So this is exam 2, problem number 2. Unit. Of y double prime minus 4y prime plus 5y of x. Okay. First, we need to find the homogeneous equation. So we convert it into an auxiliary equation. R squared minus 4r plus 5 equals 0. R is equal to 4. So it's negative b. So it's positive here. Plus or minus of b squared. The 4 squared is 15 minus 4ac plus 4 times 5 divided by 2. So this is equal to 2 minus 5. Okay. So guys, the homogeneous equation is going to be what? The first term gives you my power, so it's e to the x times b1 cosine, and it's just 1 in terms of I, cosine of x. Okay. Different d of x values. So, for example, d of x equals to 3x squared minus 1. One thing that we always need to make sure is that it doesn't match what's in the auxiliary, the homogeneous, right? Um, so here we have the polynomial x squared, so that we know our yp has to have something, like with the polynomial, it has to be in the form ax squared plus bx plus c, x squared. Homogeneous, nothing matches. For, let's say g of x is equal to x squared cosine of x. First, so I have a x squared plus b of x plus c. The trig part tells me there's a cosine component and a sine component. So if that quantity, I have plus squared plus sine. Okay. That's match quantity because we're multiplying by e. Now, the quantities by each of the two x. Okay. And then we check the match. We know the constant. So you should be able to manipulate these problems and then be able to figure them out. Okay, let's do one more. Our g of x is equal to 5x plus x sine of 2x minus cosine 2x. Okay? So we look at the first component. I have e to the 5x. Then I write a times e to the 5x here. None of it matches in the homogeneous solution, so we're good there. So plus. Next component is a trig component. So I need two of those, cosine in the trig version. And I have an x here. So that means I need to multiply by bx plus c, same degree on the polynomial, times cosine of 2x, or whichever one you want to do first, plus dx plus f times sine of 2x. Okay. And then if we go to the third one, it's the same 2x inside the cosine. Are you guys good with that problem? So the next problem that I want to do is a Bernoulli's problem. Now, that wasn't on this exam. You guys remember Bernoulli's? Sort of. Were you guys examined on that? Was it on your exam? But we're gonna do one here as well, because it's highly likely you'll see one of those. Are you guys good with this problem? Yes. So say we have the problem dy over dx plus y over x equal to x squared, y squared. So the reason we can tell we need to use the Bernoulli's method or whatever is we have a y squared here, right? Okay. So I'll just go through them. Exponent on the y, that's our n value. So in this case, n is equal to 2. We so I will have 1 over y squared dy over dx plus 1 over xy. Okay. So I'm just gonna, I don't know if you guys remember this, I'm just gonna go through solving instead of asking questions. Our v value equal to y, the 1 minus n. So in this case, that's equal to y to 1 minus 2, to y to the negative 1, which is 1 over y. If we do dv over dx, in terms of the derivative of y to the negative 1, or 1 over y, is equal to negative y to the negative 2 dy dx. So then this right here actually almost what's up there. So we actually so if we try to sub that in, we need a negative dv over dx. So we're trying to convert everything into y now. So plus our v is equal to 1 over y. So then I have plus v over x. So 1 over x times v equal to x squared. Did that make sense? We converted everything in terms of v and x. Right here, normally, what I like to do is I solve for dy over dx instead of just trying to find what matches. So dy over dx equal to negative y squared dv over dx. Right? I solve for dy over dx, negative y squared dv over dx. Then I substitute this quantity. The y squareds would cancel out, and I'd have a negative dv. Coefficients there and stuff, and it's not easy to just make that conversion. So you can solve specifically for dy dx, sub that in, and then you make that conversion. So this is almost in standard form. We divide by a negative 1, we have dv over dx minus 1 over x v x squared. Now this is form. This is our g of x. This is our g of x. And then we can use, we can try to find these and solve this. So our formula for mu equals to integral of g of x dx. So this is equal to the integral negative 1 over x dx. Yes. This g of x. That is equal to the negative log x. So if you solve that, you actually get 1 over x plus the negative exponent. So we multiply all of this equation by our mu. So I have 1 over x times dv over dx minus 1 over x squared times v equal to negative x. That's dividing that by n. So what magical thing happens here? What do we realize about this part? Gradual on something. be x. What is it the product of, or the product for? Part right here, and you it is properly. So it's the derivative of 1 over x times b. That matches, right? So this is 1 over x times the derivative of b. This is derivative of 1 over x times b. So 1 over x. Oh, sorry, negative x. We take the integral of both sides. Here is the integral of the derivative. I still end up left with b over x. On this side, integral of negative x is negative x squared over 2 plus c. And solve for v here by multiplying by x across. B is equal to negative x cubed over 2 plus c times x. And then we know our v was equal to 1 over y. So you can either leave your answer actually like this, or do y is equal to 1 over that quantity, or something like that. V is equal to 1 over y. So you can solve for y by putting this, reciprocal of it or something. Did that all make sense? So yeah, don't forget the Bernoulli's method. It's not really hard. You've done all of this stuff multiple times with different problems. You just need to know what your n value is and what your v is going to be equal to. Are you guys good with this problem then? Yeah. The next problem I want to do is annihilator problem. Okay. They had that on your exam, right? Yeah. So annihilator is part of it. Okay. So we have the problem plus 3t minus 1. Okay. So the way to do it, do this. Kind of like we have to find the differential operators that can essentially make this equal to a 0. So we can look at it in parts. The first part will so it's sort of doing the reverse auxiliary solution, where have to find what operator would take it out. So this here is t minus 1, right? This looks something like if we had a solution where there was at cubed plus bt squared plus ct. Okay. To get that, we would have had R1 be equal to R2, be equal to R3, be equal to R4. We would have had 4 repeated loops. Okay. So that is possible if we have d to the 4th power. So then each of those derivatives are R values when you current auxiliary equal to 0. That would, if we do the 4th derivative of this portion, it would equal to 0. So that's how we would annihilate that portion. Okay? That makes sense? The next part is the exponential part. That is e to the 3t, right? The way we get e to the 3t from the auxiliary equation is when r is equal to what? R is equal to 3. Because that becomes the exponent on the exponential. And that is the same thing as if I had r minus 3 equal to 0 or d minus 3. Okay. So to annihilate my entire solution will be e to the 4th times d minus 3. And this, I mean, they went through the proof before, but like it guarantees it when you multiply it too. Yeah. So I'm not even sure whether you can easily do that with sine or not. Yeah, I don't think we solved it all the way with because it became too messy. I don't think. Go back to the videos. If they do a sine problem or something, then make sure you understand that. Otherwise, I don't think I've ever seen like a sine thing with annihilators. Okay, because then it becomes too complex when you do the quadratic and everything in order to find it. But it might be possible if they cover it in the video. I don't know if any of you guys want to speak up and say that it's possible. It might not be easily possible for a handwritten exam. Any questions on this? No? Okay. Let's move on to Laplace then. Yeah, let's do a quick Laplace problem. Although you guys should be very familiar with all of this. And it's equal to 1 from 3 to infinity. Definition. So we have to do the definition. of f of t equal to integral going from 0 to 3 of e to the negative st, because that's part of the definition, times e to plus integral from 3 to infinity of e to the negative st times 1 to the constant. Integral plus e to the negative st times the function. So this portion here we can actually combine to get e to the negative quantity of s minus 2 times 2. So that when we do the integral of that, we get negative 1 over s minus 2 times the quantity e to the negative s minus 2. 0 to 3. That's the integral of that portion. The integral of this part plus the limit of negative 1 over s times negative s going from 3 to b. With that, yeah, raise the problem. So right here, we can sub in a 3 equal to negative 1 over s minus 2 quantity e to the negative 3 times s minus 2 minus 1 because the exponential is 0, 1 plus 3 approaches infinity of negative 1 over s. Here, I have this quantity negative 3 times s minus negative 3s. If I put in infinity here, when it's in the denominator, that goes to 0. So my answer equal to so I have 1 minus the negative 3 times s minus 2 quantity divided by s minus 2 plus b to the negative 3s divided by s. And s has to be greater than 0. Because that goes to 0. I'm pretty sure they're not going to continue to do that. Make sure you remember what the definition is, because they'll specifically say use the definition. So we can do a problem that uses the table. Do you guys want me to do that, or are you guys should be good with that? I think you guys are probably good with using the tables, right? Yeah. Okay, so if I have t squared then you use the formula with it. So it's the exponent divided by s to the n plus 1. So it's t squared is 2 over s cubed. Those are not hard because essentially plug and chug with the table. So the next problem that we might look at is variation of parameters. You guys remember those? We can do one of those. Okay. So this on practice exam 2. Number 7. Our equation is y double prime plus y equal to secant of t. And they want us to use the variation of parameters to find the solution. Okay. First thing we always do is the auxiliary, so it's r squared plus 1 equals to 0. I know that r1 and 2 are going to be the same, so r squared is equal to -1. So that r1 and 2 are equal to 0 plus or minus I. My homogeneous is C1 cosine of t plus C sine of t. So that my y1 portion is cosine, my y2 is sine. So the way I make my particular solution, yp is equal to b1 y1 plus b2 y2. That is equal to 1 plus b2 sine of t. The derivative of that to get y prime b1 times negative sine of t plus b1 prime cosine of t plus then negative sine of t plus b prime cosine of t plus b2 cosine of t plus b2 times sine of t. The way this method works is b1 prime cosine of t plus b2 prime sine of t. The prime components are equal to 0. And that is one of my equations that I'll use later on. If those are equal to 0, though, so then when I do the double derivative, y double prime of the particular solution, I only need to take the derivatives of the other two components. So I have v1 times negative cosine of t plus 1 prime negative sine of t plus v2 times negative sine of t plus v prime cosine of t. And now I have my y double prime. I have my y. We can plug everything back into the original equation. So we will have negative v1 cosine of t minus prime sine of t minus v2 sine of t plus v2 prime cosine of t That's y double prime, so plus y plus v1 cosine of t plus v sine of t equals to secant. So the v1 cosine of t is cancel out, v2 sine of t is cancel out. I am left with negative v1 prime sine of t plus prime cosine of t. Okay. V1 prime sine of t plus v2 cos prime sine of t equals to secant of t. That is my second equation. Any questions so far? So now it's solving system of equations. We can multiply the first by cosine. Sorry, they say multiply the first by sine, and the second by cosine. Get rid of the v1 prime terms. So if you multiply the first by this equation, I have v1 prime cosine of t times sine of t, v2 prime sine squared t equals to 0. If I multiply the second equation by cosine, I have v1 prime cosine of t sine of t plus v2 prime cosine squared t. If I multiply secant, it's 1 over cosine. If can I get it? Hold on. Is there a subtraction? Yeah. The selection minus other. So that's why they go away. And I am left with v2 prime times sine squared t plus cosine squared t equal to 1. This is equal to 1. Well, should know by now. So then v2 prime is equal to 1. We take the integral of both sides so that I get v2 is equal to t. Or v1. This equation you can work with, then v1 prime is equal to minus v2 prime. And then it'd be signed off by cosine, so that's minus v2 prime times tangent of t. We know that our v2 is equal to a t. Sorry. Our v2 prime is equal to a 1. So that if I put a 1 here, I get negative tangent of t. So then it's the integral of negative tangent of t 1 is equal to negative times the integral of sine of t divided by cosine of t dt. Derivative of cosine is negative sine of v1 equal to the natural log of cosine of t. My v1 equal to natural log of cosine of t, and my v2 is equal to t. But you can't just on the y y yp. That's equal to t1 cosine of t plus c sine of t from our homogeneous portion plus cosine of t times the natural log of cosine of t plus sine of t. So you need both portions, and then you need to state it out. Just to go through these, but you guys should be able to do the math. Remember, method requires white at the beginning and then solving. Good to move on? Yeah. The next thing is convolution. So I have a problem that we can do for that. So we are given the Laplace. We have to find the inverse Laplace of 2 over s plus 3 times s minus 1. What is one method? Partial fraction, and then solve it. But see the convolution too. This is the same thing as that as being 1 and then 1 over the second portion, right? So now it's two fractions being multiplied. The inverse Laplace of star g, and this is equal to integral of f minus times d of v d from 0 to t. First we have 2. If I take normal Laplace of that, we get e to the minus 3t. But it's we get t minus v, so this is e to the negative v times t minus v. Okay. Normally it's just e to the negative v. And then the second part, d of v, the Universal plus the 1 over s minus 1 is just e to the v. So this times dv. This right here is equal to negative 3 times e to the 3v. And add these two parts to get, so it's equal to e, sorry, 2 e to the negative 3. Because that part of the integral, with t, the integral is just in terms of dv. Times e to the v is equal to e to the 4v. So it's integral of e to the 4v is equal to 1 over 4 times e to the 4v, going from 0 to t. Does that make sense? I sort of e to the 3v times e to the v is equal to 4v. The integral of e to the 4v is 1/4 e to the 4v. So now we plug in t at the negative 3t times the quantity e to the 4t minus e to 0. So this goes to a 1, this is equal to 1/2. Negative 3t times 4t, we add them to get e to the t minus e to the negative 3t, which is multiplied by 1. Are you guys good with this problem? Okay. Let's do a unit step function problem. Let me know if you guys need like a little break or something. Like we probably won't go, all the way till 8:30, but there's 3 other problems that I'd like to do. Okay? Make sure you get. Okay. We have the function f of t equal to 3, 5, 0, t from 0 to 1 is 3, from 1 to is -5, from 3 to 4, 0, and from 4 to infinity, it's t. And step functions are something that you'll continually use in most of your upper level classes. So we have to find the step function and then take the Laplace of it. F of t. So essentially you treat it like an on and off switch. So it's the function 3 when it's u of t. So it's function is turned on. It's turned off. That's -3 when time is equal to 1. So that's u of t minus 1. Minus. Now it's turned on, so it's a plus -5 function, so -5. And it's turned on at t minus 1. Subtract at -5. and then t minus 3. And then for the rest of the time, it's the function t times u of t minus 4. And that's so I think about it as like this, because we can combine some components. So I have 3 u of t. So the minus 3 minus 5. So I have a minus 8 u of minus 3. Sorry, t minus 1. The other thing, 0 wouldn't matter. Right? I didn't write that. 0, 0 times anything. So the next part is 5. And then I have plus. Part is doing a plus of that. F of S is equal to, so you can use the table. The Laplace of u of t is 1 over s, so it's 3 over s here, minus 8 over s. But since it's u of t minus 1, I have to multiply by e minus s. So then I have plus 5 over s. And it's u of t minus 3, so it's e to the minus 3s that are multiplied by 5. So then this part weird. It's u of t minus 4, so then I have e to the minus 4s. But I have to do the Laplace with plus 4. Right? What is it squared? Then the idea is that I need it to look like t minus 4. So then I can do t minus 4 plus 4. Okay. So then this relates back to the t, but then I have a quantity plus 4. So when I do the Laplace, I need to do it from. So this is my t portion plus 4. Or do you guys follow it? You need the t to be in the range of t minus 4, so t minus 4 plus 4. So the Laplace plus 4. I think there was a problem in the video that went through this. Might have added on an exam or a quiz. But this is me trying to remember what happens. But here we have squared. Okay, that doesn't easily translate into something. T squared will be that, right? So then I will do t minus 4 plus 4 quantity squared. Okay. I treat t minus 4 as one portion, so then it's t minus 4 quantity squared plus 2 times 4 times t minus 4 plus 16. And then this, when I convert it back and do the Laplace of it, t minus 4 is treated like t squared plus 8t plus 6 if I did that correctly. Did that make sense? So then this quantity here, t squared plus 8t plus 16, that is what you need to do the Laplace of. I'm like 90% sure I did that correctly, but just understand the idea where it's like, it's not that simple when you have a function outside of the step function. And just do the inverse Laplace of that and get away. Yeah, but it's easier to take the Laplace of that then. Any questions on that? Okay. Let's move on to unit 4. So the next two problems, like I try to avoid problems that you guys recently did, / stuff that was just a lot of writing, since you guys should be able to do the algebra and everything by now behind it. So I tried to cover mainly concepts here. So let's do the transfer function and how to find that. All right, this is 4, number 1 from the old example. We have to find the transfer function h of s. So I have y double prime plus 3y prime plus 2y equal to g of t. Y of 0 is equal to y prime of 0 equal to 0. Transfer functions are in the S domain. S squared y of s, since the rest of them are 0, not necessary to write them down, plus 3s y of s plus 2 y of s. Okay. Use to convert from y of s to g of s. Go essentially from your input to output. But this is how we find it. Y of s over g of s is equal to h of s. So that's something you can do. So then we solve for that. I have 1 over s squared plus 3s plus 2. I grouped all the y of s together and divided by that factor. So this is equal to 1 over quantity s plus 2. the time domain H. What does this look like? And if you want to equal to A over S plus 2 plus B over S plus 1 is equal to the limit as S approaches the -2 of the quantity 1 over S plus 1. You guys all understand that, right? I multiply by S plus 2 to everything. S goes to 0 when S is equal to -2. So here, I plug in a -2 here, get a -1. -2 plus 1 is equal to -1. For B, limit as S approaches quantity 1 over S plus 2. For S, I'm left with a 1. My A value is equal to my B value is equal to 1. Inverse Laplace of that gives us our A. What is the inverse Laplace of negative? What? And then plus -1. So it's the opposite sign. That would be random. On this or something, you would have your input, you would apply this function or something, and then you would get an output. Go over all the mass and the spring stuff. That was pretty recent, so you guys should be able to remember that. But I'm in the exam review. I did that whole chart, right, with each case and stuff, and that's on the video too. So make sure you look at that. That pretty much covers the formulas and stuff that you need to know, like damping factor or quasi frequency. Okay. So the last problem that I really wanted to cover is converting a differential equation into a first order differential equation when it's like d to the 4th derivative, right? So those aren't hard, but I just wanted to cover that so that it's fresh in your mind. Okay, so this is from exam 5, number 1. So we're almost done. Let's. I have d to the 4th y over dt to the fourth minus 3 dqy over dt cubed plus 2 squared y over dt squared plus 5 y over dt plus y equals the cosine of tell us that f 0 is equal to 1, y prime of 0 is equal to 2, y double prime of 0 is equal to 3, y triple prime of 0 equal to 4. So first, we always set x1 equal to a y. Take the derivative of that, you get x2. That's equal to x1 prime, y prime. x3 is the derivative of x2, so that's x prime, which is equal to y double prime. X to the fourth, or x4, is equal to x3 prime, which is y double prime. And we don't create x to the fifth variable. We say that x prime of x4 prime is equal to y fourth derivative is equal to, this is our equation, y to the fourth derivative, we solve for that, but cosine of t there plus y triple prime minus 2y double prime minus 5y prime. Now we can convert all of these y terms to x terms, so that we have x to the fourth prime equal to cosine of t plus 3 y triple prime is equal to 3x4 minus 2 x3 minus 5x2 minus x1. We have x1 prime equal to x2 is equal to x1 prime, x2 prime is equal to x3, x prime is equal to x4. Essentially, the equation that we got here. So now I have 1, 2, 3, 4 equations with 4 different variables, right? And this is the first order the equation. Y x1 of 0 equal to 1 of 0, 2 x3 of 0 equal to 3, x4 of 0, 4. Need all of this. So, but you should be familiar with the method in getting that. You don't want to miss an easy pointer. And then, what the next step with that sort of thing is you can do system of equations or something. Solve them. But those are the problems that I have. Do you guys have any problems? I was gonna. So one other thing, don't forget how to find the two ordinary differential equations with partial DEs. Do you guys remember that? Let me, guys, calm down. Let me say this quickly. We have a partial differential equation. Two ordinary differential equations. Actually, let me do this quickly. So we have partial derivative, second derivative of u equals to 4. Second derivative partial of u in terms of x plus 2. So we have, so this is a partial d, but u is being taken derivative with respect to x and with respect to y. Okay. That is our equation, and this is the part that will vary between problems, but we assume that the solution of u in terms of x and t is equal to x of x times t of t. You guys remember this problem, right? I'll just solve it quickly, but it's another thing that if you get it on the exam, it's easy and not too. Remember short steps. Derivative, partial derivative of u with respect to t squared. So it's a partial derivative, and if this is my model equation, the x component stays like a coefficient, and then it's being multiplied by the double derivative t. If I'm doing the partial derivative, second derivative u with respect to x squared, the t remains like a coefficient, but it's a second derivative of x. Okay. So those are, this is my equation. I plug into the equation. So then we get x t double prime equal to 4 times x double prime times t plus 2 times x u. Separate the variables, like we bring t to one side, x is to the other side. So on the left, I have t double prime divided by t. On the right, let me do that a bit more slowly. So I have t double prime. I can have t. How does it? I'm going to bring all the x components to one side. Components. Can I do that easily? So on this side, I have x times t, and that does not work. So I have x t double prime equal to t times 4x double prime plus 2x. By t on this side, so I have t double prime divided by a t equal to 4x double prime plus 2x divided by n. Right? They are both. I can set this equal to constant. So the first equation would be t double prime. If I multiply t to the k, I can do t double prime minus t times k equals to 0. And my second equation, 4x double prime plus, so it would be plus 2x minus k equals to 0. Minus kx equals 0. Right here, you can actually simplify it by x times the quantity 2 minus k. This will be your solution. So don't forget this if you have that on the problem exam. And then, yeah, for the Eulers and the Runge-Kutta method, they should give you the formulas. So those, make sure you review it, but those shouldn't be hard. Fourier sine or cosine series, do a sample problem of each, so that you know how to simplify it when a part of it equals odd and a part of it equals even. Does that make sense? That's it, guys. Thanks for coming. Make sure you signed in.